Hi everyone, welcome back to Data Cadence, and this is another very important interview question, which is a very common one. So the interviewer asks you to explain in detail the assumptions of the linear regression model. So this is a very common interview question to test your fundamentals and basics, because if you're not being able to answer such basic questions, it is a clear red flag for the interviewer, and it's a clear and a very strong message to the interviewer that this guy doesn't really know about the basics. So make sure that you are aware about this particular question and you know how to answer this. So these are some of the assumptions that you might be aware about, but the thing is that the interviewer wants to know your depth of understanding of concepts. So he just doesn't want to hear all of these assumptions. A lot of people just mug up these assumptions and present this to an interviewer, but when he starts going into the details of each of these assumptions, the candidate many of the times are not able to explain what do each of these mean. So we'll quickly go over these and we'll try to understand how we can basically explain these in a little more depth. So the first assumption is very obvious, that there should be a linear relationship between your target and the features. That's quite obvious. That's why the name is linear regression. The second assumption is that there is no or very little multicollinearity between your features. Now, a follow-up to this particular question from the interviewer could be that how do you test for this? So we'll talk about each of these assumptions in detail in the subsequent slides. So yeah, stay tuned. And the third assumption is homoscedasticity, which means constant variance. Again, how we can test for that, we'll talk in the subsequent slides. The fourth assumption is normality of residuals, and the fifth one is no autocorrelation of residuals. So as mentioned, these five assumptions, anyone can mug up and speak up. But if the interviewer starts going into the details, that's where you should know what do each of these mean and how you can test for each of these. So let's look into that. So the first one is how to check for multicollinearity. Okay, the very first assumption that there should be a linear relationship between your features and your target, that is quite trivial. So I'm not going into that. So yeah, let's talk about multicollinearity. So to check the multicollinearity, the first approach that you might present is that you can always go for a correlation matrix, and that is quite trivial and that makes sense. So that is a valid answer, and which a lot of people will give, and that's acceptable, no issues in that. But another very interesting aspect to look at multicollinearity is the variance inflation factor, also known as VIF. So VIF is basically predicted by taking a feature and regressing it against every other feature in your dataset. And the VIF score represents how well the variable is explained by other independent variables or features. So VIF is calculated as 1 over 1 minus r squared, and I'm sure that a lot of you might know about r squared. So r squared value is determined to find out how well an independent feature is described by every other independent variable in your dataset or features. When I say feature or variable, I mean one and the same thing. And a high value of r squared means that your variable is highly correlated with the other variables. So when you have a higher value of r squared, the denominator, that is 1 minus r squared, will get low. Why? Because r squared value will get closer to 1, and that's why the denominator will get low, and the overall variance inflation factor for that particular variable or feature will get high. So simply speaking, if the variance inflation factor is 1, that implies almost no correlation between the independent variable and other variables. A variance inflation factor of more than 5 indicates that there is a high multicollinearity of a particular feature with other given features. And a VIF of greater than 10 indicates extremely high multicollinearity. So this is one such example where you have a particular variable and you have VIF. By the way, the implementation of VIF is very simple and you can find it in libraries like SciPy. So you can definitely use those to calculate VIF. And this is one such toy example where you have basically 4 features, and you can see that the variance inflation factor for age and years of service is quite high. It's more than 10 for both of these cases. So how do you solve for this? You basically drop one of these features which has, let's say, a higher VIF. So in this case, we drop the feature age, and after dropping age, you basically calculate the VIFs once again, and now you see that the VIF for the years of service feature has reduced. So yes, dropping the variables with high VIF could be one of the possible solutions. Let's talk about the other assumptions. So homoscedasticity. So as explained before, it means constant variance. So how you check for this is you simply plot your residuals against your predicted values using a 2D scatter plot. So residual is a very commonly used term, and that basically means the observed value minus the predicted value from your linear regression model. And if there is no pattern observed in this particular plot, you basically have a constant variance or homoscedasticity. And if you want to quantify this pattern, which I have mentioned above, so you can basically compute the covariance, or correlation would be a better choice, between your predictions and your residuals. And if that correlation value is low, you can say that you have homoscedasticity in your dataset. Then let's talk about the normality of residuals. So again, you can use standard ways to check for normality. So you can obtain your residuals, that is the observed value minus the predicted value. And you can use standard methods to test for normality, like KS test, which is a statistical way of testing normality. Then there are things like quantile plots, that is QQ plots. So those are some of the things that you can use. And the last assumption is no autocorrelation of residuals. So for this, again, you can plot the autocorrelation plot to determine this and see whether there is any autocorrelation corresponding to any given lag window on the x-axis. So these are some of the things which you should be aware about. Just stating the assumptions won't do any good, because if the interviewer is looking for more details, then you should be able to provide these. And if you provide these details by default, then certainly you stand out compared to a lot other candidates applying for the same role. So yes, this was a very short video covering some of the assumptions of linear regressions and some of the details to understand them in a much better way. So yes, thank you for watching this particular video. If you enjoyed this and gained something out of this, please appreciate by pressing the like button and subscribing to this particular channel. And if you have any suggestions, I'm open to those. You can drop them in the comments below. So thank you so much for watching this particular video, and see you in the next one then. Bye and take care.